All right, so this is the last part of chapter 5, and this is over Cpctc. So let's get into what that just might mean. All right, first off, remember when we did proofs in chapter 2? Well, we're going to do them a little bit today too. So given. So BC is congruent to DA. So BC is congruent to DA. It was already marked, but I'm just reiterating. BC is parallel to AD. BC is parallel to AD. Again, it was already marked, just putting it on there, okay? So they have marked BC is congruent and marked it given. BC is parallel and it's given. Now the next thing here is I know that because these two lines right here, BC and AD, because they're parallel, this segment right here is acting as a transversal. So that means this angle is congruent to this angle. So angle BCA, which would be this one right here, is congruent to angle DAC, which is this one here, because they're alternate interior angles. I also know that this side right here is congruent to itself because it's part of both triangles. That's my reflexive property. Now I can see that the triangle here, so let me slide this over. So this triangle here on the top, triangle 1, BCA, is congruent to triangle 2, the one on the bottom, DAC, by side, angle, side. So I'm just going to put side, angle, side here. This is exactly the same thing we did in the last lesson. We just didn't write it out. Like we said, hey, these two sides are equal, this side's equal, these two angles. We said all of these things. We just didn't write them down. Today, we're just going to write them down, okay? All right, so this is what Cpctc stands for. So I am going to type it. All right. So the C is for corresponding, and I don't need a bullet. So corresponding. So C is for corresponding, P is for parts. And again, I don't know why it's bulleting everything. Corresponding parts of congruent triangles are congruent. And again, I don't know why. And here, I'm just going to copy that word. There we go. So Cpctc stands for corresponding parts of congruent triangles are congruent, meaning if my triangles are equal to each other, all their parts are also equal. That's all that stands for. It's just a really quick way of saying it. So Cpctc is used when asked to prove that the parts, the corresponding parts of a given triangle are congruent. So triangles must first be proven that they are congruent. So we have to prove that the triangles are congruent before we can use Cpctc as a reason. Oops. That one got a little crazy. So before we can use this Cpctc as a reason, so you will never ever use side, angle, side, 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 or any of that. You will actually, let me rephrase that. You will never use Cpctc before you use corresponding parts of congruent triangles. So you will never use that reason before you actually tell me the triangles are congruent. So you're going to have to say, hey, these two triangles are equal to each other before you can use this reason. Okay? All right, so let's go through and see what that looks like. So the very first thing I did on the front was this. I already did this, okay? We already said these two sides are equal. It's given. We already said these two sides are parallel. It's given. We already said that this angle here is equal to this angle here because they're alternate interior. And we said that that side was equal to itself because it's part of both triangles. All right. So we already said, hey, this triangle here, ABC, is congruent to CDA by side, angle, side. So this is the same proof that I did for you right here. The only thing that's different now is they're asking you to prove that the parts are equal. So they want to see that this part is congruent to this part. So they want me to prove. So let me put the little sign here. So since this triangle, the top one, number 1, since it is congruent to triangle number 2, if the triangles are congruent, their parts are also congruent. So this would be Cpctc. So once you use this, you can use this next, as long as it's asking for parts. Okay, so let's see what else this looks like. So how do you know if the last step is going to be a Cpctc? Look at the prove statement or that last reason. So if it says triangle is congruent to triangle, you're going to use one of these reasons. If it says a part is congruent to a part, corresponding parts are congruent, then Cpctc will be your last reason. Okay, that's how you know. All right, so here's the hidden information again. We're going to keep talking about this. So results in 2 segments being congruent. If A is the midpoint, so if A is the midpoint of EB, then I know that AB is congruent to AE. So if it tells you there's a midpoint, then you can bet there's going to be 2 parts that are equal. Results in 2 triangles being congruent. If AD bisects angle BAR, so if this bisects angle BAR, then BAD, this angle here, is going to be congruent to RAD, which is this angle here. So if it bisects, then you're going to have 2 equal parts. Again, this is hidden information, stuff they expect you to know because of the word bisect. If 2 angles are vertical, they're going to be congruent. Again, they expect you to know because these are definitions. All right, when the triangles have a side in common, so when they share a side, this is going to be that reflexive, okay? So when they share a side. When lines form right angles, so when BD is perpendicular to CD, then these 2 angles are both going to be 90. So they're going to be right angles, therefore congruent. Now, if this side is parallel to this side, then they're going to expect you to know that those 2 angles are congruent by alternate interior angles. That's why I told y'all when we did chapter 3 that you need to make sure that you get that so that you know what's congruent. So always look for parallel lines, look for that transversal and the alternate interior angles. When the angles are right angles, look for those perpendicular lines. So perpendicular lines. Look for the reflexive property. Look for vertical angles. Look for the word bisects, angle bisector. Look for the word midpoint. Those are all things that are going to give you information that's automatically expected to know. All right, here we go. So here's our first proof, and here's some banks over here, so you're not completely filling this in, okay? So TV is congruent to WV. So TV is congruent to WV. That's given. Check. Angle T is congruent to angle W. Angle T is congruent to angle W. Again, that's also given. All right, now I know that this angle right here is equal to this angle right here. So that would be angle TV. Oh goodness. Let's see. This is angle U. All right, so angle TVU, so angle TVU is congruent to WXV. So angle WXV, and these are vertical angles. Vertical angles are always congruent. Now, what congruence theorem? So I've got this angle, and the side that connects them. So this is angle, side, angle. So triangle TUV is congruent to triangle WXV by angle, side, angle. Okay, so that is the congruence theorem that they wanted me to use. So this is a side, this is an angle, and this is an angle. So this came out to be angle, side, angle. All right. So make sure if you have questions, I'm going to go on and do the teach piece in a separate video, but make sure that you are asking questions if you need help. See y'all later. Bye. Okay, apparently I'm not doing the teach piece yet. I left off a question. So we are going to go and do this last question, and then I will make a separate video for the teach piece. I apologize. Surprise, I'm back. All right, so here, I'm going to go through and mark up my picture. So RT is congruent to UV. RT is congruent to, so RT, oops, that's not RT. My letters are not very clear. I hope yours are more clear than mine. RT is this one here. It's congruent to UV, which is over here. And this is given. And that is a side. RS is congruent to UR. RS is congruent to UR. RS, UR, this is also given. So it looks like they have given me a lot of information. This is also a side. Angle T and angle V are right angles. So angle T and angle V are right angles. This is also given. All right, let's see. So since they're both right angles, that means they are congruent to each other. This is a right angles theorem. All right angles are equal to each other. So this is the right angles theorem. So the right angles theorem. Now, why are these two triangles congruent to each other? Because notice my step right here says that triangle TUV is congruent to triangle WXV. So why are they congruent? Well, since they are right triangles, and I can see here that this hypotenuse is equal to this hypotenuse, and this leg is equal to this leg, then I know they are congruent by the hypotenuse leg theorem. Now, notice they want me to prove that this piece right here is congruent to this piece right here. So TS is congruent to VR, because if the triangles are congruent, all their parts are congruent. So Cpctc, corresponding parts of congruent triangles, are congruent. In other words, if the triangles are congruent, their parts are congruent. So now I have used all of them in my bank, and I have finished all of the questions in the notes. So I will say goodbye again, and I will see you guys next time. Bye, for real this time.